Okay, good morning. Today we're going to talk about solving rational equations. And rational equations are of the form where they have one side is rational and the other side is potentially rational as well, but maybe not. Alright? For solving rational equations, the first step is always to cross multiply. So I can make it kind of pretend like this is written over 1, and I can say 20 times 1 is equal to one side, and then this times this is equal to the other. And now I've gotten rid of the rational. That's basically the first step in rational equations. Alright? So even though I had two terms over here, x plus 2, I put the entire thing over 1 and treated it as if it were its own thing. And now what I'm going to have to do is I'm going to have to multiply this out. 20 is equal to x to the third. Is this times this. Then I've got x times a negative 4x squared, or minus 4x squared. This x times that. Plus 7x. This times this was that. Now I move on to the 2. Plus 2x squared. This times that was 2x squared. Then I've got minus 8x. 2 times a negative 4x is a minus 8x. Then finally plus 14. 2 times 7 is 14. So I've basically taken all three of these and multiplied it with both of those for a total of 6 terms. Now I notice that I've got some like terms. I forgot my x here. Alright, because that was a 7x. Now I've got 20 is equal to x to the third minus 2x squared minus x plus 14. Alright, and now if I subtract 20 from both sides, I'm going to end up with a 0 is equal to x to the third minus 2x squared minus x minus 6. And now this, everyone, is a simple third degree polynomial which I can factor by writing down the rational roots. The rational roots are either positive or negative, 1, 2, 3, or 6, because of my 6 over 1 here. Remember, it's 6 over 1 will give me my rational roots. So I'll start with 1s, 2s, then 3s, then 6s. I'll just kind of eyeball it here. The 1s aren't going to work, it looks like here, because I got 1, this is a negative 6, so this is only ever going to be a 1, and a 2, which could only be a 4, and so that's not going to work. Let's see, the 2s, this is an 8. This is also going to be an 8 minus 8. I could get, but then I'm still left with a 6. The 2s aren't going to work either. So let me try the 3s. I can't do the 3s so well in my head, so I'll just write down the 3s here. This is a minus here. Let me just check to make sure I wrote that down correctly here. Alright, so 27, 9 minus 2 minus 18, minus 3 minus 6. Hey, this actually is 0. So if 3 is 0, then one of the factors of this is x minus 3. now I'm going to have to get the other factor over here. But remember, I'm going to try and pull out the x minus 3 with synthetic division. And I use my original function here. Actually, no, this is not written in the correct spot. Let me just write x to the third minus 2x minus x minus 6. If I pull out an x minus 3, I'll be left with another factor here, okay? Because I found that f of 3 was equal to 0. Alright? And so, pulling out that 3, I will do with synthetic division. So remember, synthetic division is done if I have a 3, or if my factor is x minus 3, I write down a negative 3, and then I write down the coefficients 1, negative 2, negative 1, negative 6, 1, negative 2, negative 1, and negative 6. And then if I've written down the same thing, I didn't change the sign, then I do subtraction. So I'll write down a 1. Negative 3 times 1 is a negative 3. And then I subtract. Negative 2 minus a negative 3 is 1. Then I've got a negative 3 times 1 is a negative 3. Then I've got a negative 1. And a negative 3 is a positive 2. Remember, I'm subtracting here. So a negative 3 minus a negative 3 is a positive 2. Then I've got a negative 3 times a 2 is a negative 6. Negative 6 minus a negative 6 is a 0. And then, sure enough, got it. And so, my other is x squared plus x plus 2. X squared plus x plus 2. And so I've got x minus 3, x squared plus x plus 2. And actually, if you look at this, there's actually, this has no zeros. Because they're all positive, all of these. This is positive, and this is a square, so it's positive. So this will never actually achieve a negative number. And so it looks like the only solution is x plus, or sorry, is when x minus 3 is 0, and so that is when x is equal to 3. Now, for this, you want to check the denominators. Alright, so what I mean by that is I actually now have to go way back up to my original question, way up here. And I actually have to put the solution, x equals 3, into the denominators. So I'll rewrite my question down here. It's 20 over x squared minus 4x plus 7 is equal to x plus 2. Okay. So what I want to do, this is a solution that I found. What I would do is I'd take all the solutions that I found and I'd plug them into the denominator here and see if I get a 0. Because remember, you can't have a 0 in the denominator. So I'm just going to say x squared minus 4x 3 squared minus 4 times 3 plus 7 cannot equal 0. If it doesn't equal 0, then this actually still is a solution. So I've got 9 minus 12 plus 7, and this is 9 and 7 is 16 minus, this is a 4, and so this is a okay or a good solution. Let me zoom out a little bit here. So let me go back up. So what we did is we took this and cross multiplied, and then we multiplied out this side and ended up with this excuse me. Right there. Oh, excuse me. So basically, the only new thing for this chapter is, or for this section, is you have to take and you cross multiply everything and you get a polynomial. Once you get that polynomial, then you go ahead and you go through the classic factor polynomial thing here. Now, another new thing was that the second factor that we got right here was a strange factor in that it didn't have any zeros. Normally you would be able to factor this and you would get 2 more solutions. Okay, but in this case, since it's an odd one, you actually don't. Okay, and so that's basically the idea for rational equations. Rational equations. I'll do one more. Okay, example 2. Let me go grab one from somewhere nice here. Let's do this one here. 3x plus 5 over x minus 4 equals 1/2. This one is actually going to be pretty easy because there's no x squareds. There's no x squareds here. And so what I'll do is, again, I'll just cross multiply. I actually already have a fraction here and a fraction here, so I'm going to get 3x plus 5 times 2 is equal to an x minus 4 times 1. Okay? And so now I distribute in this 2 and I get 6x plus 10 is equal to x minus 4. Now I'll pass everything over to, actually this is super easy. This is like grade 7 one here. And so I get 6x minus x is equal to a negative 4 minus 10. Basically what I did is I passed the number over here and the variable over to there, so that way I can isolate my x. These are common terms or like terms, so I get 5x is equal to a negative 15, sorry, negative 14. And now if I divide both sides by x here, I get x is equal to a negative 14/5. That one was pretty easy. So now what I want to do is go back and check the denominator here. Is a negative 14/5 placed in the denominator, is that going to give me a 0? So remember, or basically, x cannot equal 4 here. So is this 4? No. So this is a okay. This is a good solution. Check. Let me do another one, since that one was so fast, I guess. let's do this one here. 4 3x minus 5 is equal to 4. Oh no, this is pretty simple as well. That's just like the one we just did. Sorry, I'll get a better one. X minus 5, x squared minus 3x minus 4 is equal to 3x plus 2 over x squared minus 1. Okay, now what I would normally do is I would just cross multiply here. But before I do that, because if I cross multiply here, I'm going to get some crazy stuff. I'm going to get big giant stuff going on here. And so what I'm going to want to do is check to see. I'm going to factor these things first and just see what happens. Alright? Because I actually might have, and I'm actually looking like I can see that if I factor this and this, if these have common factors, then we can avoid a lot of our problems by finding the common factors here. So I got x minus 5 over x minus 4 and x plus 1 is equal to a 3x plus 2. This is the difference of squares, x plus 1 and x minus 1. So again, I just factored these denominators. Why did I do that? Because hey, look at this. I actually noticed that I have a common factor here, right there. Alright? If I have a common factor, I'm going to avoid a lot of problems. And so, what I'm going to end up doing now is I'm going to get a, I'm going to multiply multiply both sides of the equation by, here, multiply both sides by x minus 4 times x plus 1 times x minus 1. Alright? And so what I'm going to do is I'm going to get some space here. So this is going to be big news. Why am I doing this? Check this out. If I do it this way, remember, you can multiply both sides of an equation by anything you want. X minus 4, x plus 1, x minus 1. I'm going to multiply that side by that. X minus 4, x plus 1, and x minus 1. And I'm going to multiply this side by that. And now remember, if you multiply a fraction by a fraction, it's as if these are over 1. And I'll put parentheses around these guys here. And now look at what happens is I've got a common factor here, so they actually cancel. I've got a common factor here, those cancel. I've got a common factor here and a common factor here. And I'm left with x minus 1 times x minus 5 over 3x plus 2 times x minus 4. And this is a lot more simple than what we would have gotten had we just cross-multiplied in the beginning. Alright? Another way of looking at this is to look at this here and notice I have a common factor and just multiply it by that common factor, x plus 1 and x plus 1. If I multiply both sides here by x plus 1, bang, those cancel, bang, those cancel, and I'm left with x minus 5 over x minus 4 is equal to 3x plus 2 and x minus 1. And now what I could do is I could cross multiply to get this, and I could cross multiply to get that. I know I did that fast, but if you didn't understand it, rewatch it a few times and see that I did it in two ways. Basically, I did it this way, where I multiplied both sides by a big thing, or you can do it more quickly by just multiplying both sides by the common factor. Then the common factor cancels. Now that the common factor is canceled, you can now cross multiply and you get this. Now, how do I solve this? I FOIL this side and FOIL this side. X squared minus x plus 5 minus 5x. I just took and I multiplied that by that, this by this, this by that, that by that. And I get 3x squared minus 12x plus 2x minus 8. Now I take each of these and I'm just pass everything over to one side. 0 is equal to a negative x squared. Pass that over. Plus x. Change the sign. Plus 5x. And minus 5. Passed all these over and changed their signs. Passing those over to this side. Plus 3x squared minus 12x plus 2x minus 8. Okay, it's looking big and mean, but it's actually not, because look, I've got a common term here. Here's some x terms as well. These are all going to go away, and then these here are also common terms. And look at what I'm going to get, actually. Something super simple. Negative x squared plus a 3x is a 2x squared. Got it? Got it. X and a 5x is a 6x. Plus 2 more is 8. Minus 12 is a negative 4x. Then the 5 and the 8 is a minus 13. And now I've got this. And that, my friends, is very easy to factor. But what I'm going to do is I'm going to use, what you can do is use the quadratic formula, because this actually is not easy to factor. It's 13 and 4. There's no combinations. So I would say a negative b plus or minus the square root of b squared minus 4ac over 2a. And then you basically plug the a, the b, and the c into the quadratic formula. We all know how to do this, so I won't spend much time on this. But I end up getting, after I use the quadratic formula, I get 2 plus the square root of 30 over 2, or 2 minus the square root of 30 over 2. These are the two solutions to this up here. Okay? And so what I want to now do is I want to check to see if these numbers are any of these denominators. So what I want to do is I want to look at my original denominators. My original denominators are here. So basically what this means is if I look at these denominators, x cannot equal 4, negative 1, or positive 1. And so if I go and I look down here, x cannot equal 4, negative 1, or positive 1. If these are any of those numbers, then I would cancel out that as an answer. But in this case, these are not those numbers. So these are the solutions. that one was a quick one. Well, it was kind of quick. And so what you want to do is go over that again, maybe, or just kind of check it out. By the way, that one is actually example 1B right there. I just kind of did example 1B on page 177 in the textbook right there. If you wanted to just go over that, notice what they've done here. Multiply both sides by and then on the other page here they solved it with the quadratic formula and so forth. Alright, and so there we go. That's rational equations. There's several different kinds. You're gonna have to practice a few of them, okay?